Hello and good morning, CSI 135 students. The following is the video tutorial solution set for lab number 6 from week number 6. Alright, question number 1. It says there is a directory located in the following location on the class system, and the directory is /temp/m/me/mem/memo/memos, right? So here we are, and let's see what we have in this directory. Alright, a number of files that all begin, the majority of them begin with the same character. Alright, so your task is to examine the commands provided to you below and list out for each of the commands the files that would be displayed. So again, you could go ahead and simply run the commands here, right? And that's what I'm going to do. The first one is ls space, ls space, a little typo in there, and then it's open bracket 0-9 question mark, keeping in mind that the 0-9 is going to match one character and one character only, and that the question mark will match 2 additional characters and only 2 additional characters, and they have to match something. So it's going to match any single digit, file name that begins with any single digit, followed by any 2 characters. And so as you would expect, it's only going to match 777. Now it does not match 4 7s, because what we're saying is this is one character followed by a second character followed by a third character, right? And the first character has to be a number. Alright, the next command is ls, and then it's 0-5 and the asterisk. And what is this going to match? And as you would expect, it matches nothing, because there's nothing in the directory that begins with a number 0, 1, 2, 3, 4, or 5. So it matches nothing. How about ls question mark, open bracket 0 through 7, close bracket, question mark, asterisk. So again, remembering that the question mark can match one character and only one character, followed by any single digit 0 through 7, followed by 2 digits of any character, number or letter, followed by 0 or more of anything. So what begins with one character immediately followed by a digit? Well, that eliminates list, but it doesn't eliminate the 7s here, the file names we have that begin with 7. So it could match this, followed by that, and then 2 more characters. So now we're all the way up to 777, followed by 0 or more of anything. So, as you would expect, it's going to match 7777, and then 77778, and then 4 7s and 2 8s. Alright. The next one is ls question mark a through z, lowercase, and that's key, critical point there, because Unix is case sensitive and Linux is case sensitive as well. So ls question mark a through z question mark. So the first character, represented by the question mark, can be any character, but that character must be followed by an alphabetic character that's lowercase, excuse me, then followed by any 2 characters. So here's a character followed by a lowercase character a through z, followed by 2 characters. Now the question is, will it match list? And it should match list as well. So we should see 2 file names here, right? List and list. Okay, the next one, which gets a little more difficult, is ls question mark a through z, close brackets, question mark, and then 0 through 4, right? So this will match any single character followed by any lowercase alphabetic character, followed by any 2 characters, followed by the number, or any number, 0 through 4. So we've got an alphabetic character here, followed by a lowercase alphabetic character, followed by 2 characters, followed by 2. So my guess is it's only going to match list 2. And that's true. And remember, the difference between the asterisk as a special character on the command line and the question mark is the asterisk matches 0 or more of any characters, right? So it doesn't have to match anything like we saw here. So there's 1 character, 2, 3, 4, and then we have the asterisk. But it matches these 4 characters. Again, the asterisk does not have to match, but if it does, it will match any and everything that follows. Okay, on to the next one. LS question mark, and then we've got A through Z, followed by 0 through 9, question mark, question mark. Now this construct, in between the brackets, says it can be any single character that's a lowercase alphabetic character or a number 0 through 9. So what would this match? It's going to match 1 character, uppercase or lowercase, or a number followed by any 2 characters, but they have to match. So basically it's 4 characters, with the second character being either a lowercase alphabetic character or a number. And so you can see 4 characters in a match, 4 characters in a match, and then 4 characters in a match. And remember, right here we say lowercase. The question mark, it's any single character, uppercase, lowercase, or number, right? And it has to match at least 1 character. Okay, so the next example we have, and let's list out our directory again. The next example we have is ls, and we have 0 through 9, followed by 0 through 9, whoops, 0 through 9, followed by 0 through 9, question mark, and then the number 8. All right, so what are we saying here? We're saying that the first character, we can actually take a look here and see, it's going to be 1, 2, 3, 4, 5 characters. So whatever the string we match is, it's going to have to be 5 characters, and that string has to begin with a number, 0 through 9, followed by another number, followed by any 2 characters. This could be upper or lowercase alphabetic characters or numbers, and ending in 8. And a quick look here, we can see that it's not going to match any of our lists, right, or L, Li, LST, because none of them end in 8. So let's see, we should get 1 match, and that's 4 7s. So that would match 1 7, 2 7s, 3 7s, 4 7s, and then the number 8. All right. And then our final one is ls, and we have A through Z, whoops, capital A through Z, and then lowercase a through Z, and then 0 through 8. All right, so one of the strategies that you can use is to figure out how many characters, especially when the asterisk character is not in play. So this is 1 single character, right? Even though it's going to match an uppercase letter, a lowercase letter, or a number 0 through 8, it is 1 single character in the string, followed by 2 characters. So right now we know that the maximum number of characters this will match will be 3. And we know from the first character that it can be any letter, upper or lowercase, or any digit 0 through 9. So we will get a match from both the numbered files, the files that have numbers for their names, as well as the files that have letters for their names. But only 3 characters. And there you have it. Okay. All right. Of the files in the directory which we're in here, which of them are hard links? Right? So let's take another look here and let's see what we've got. Whoops. So ls-lai, so I want to see the hidden files. And so we can take a look here. And remember, we talked about the link count, right? And the link count, if it's a regular file in the directory that we've created, right? And if it's 2, it would indicate that these files are linked. Now, the question asks you, which files are linked together? And so it wants to know which ones match. And so by using the -i with the ls command, it lists out the inode number of the files. So if I were to look at the first file here, 77, there's the inode number, 3159939. So then we're going to try to find a match for that, 3159939. So there we go. So 77 is linked with list 2. There's also some other files here. So we have 4 7s, right? So 7777. And that is 315, inode number 3159932. So here's 3159932. It has 2 links. So 4 7s, 7777. That file is linked with list 2233. All right, there's one more in here, and it's this guy right here, 3159936. And here's his partner right here. So L is a hard link to 3159936 or LIS, right? So those are the 3 sets. Now, question 2 also asks you, or I'm sorry, question 3 asks you, without using the ls command, what is another method you could use to provide the answer to number 2 above? And if you remember from the lecture, the stat command can be used to show you a lot of very valuable information. And another piece of that information is the inode number. So if you stat the file, it will show you the inode number. Now this may take a little longer, as you would be expected to have to go through and stat every single file in the directory, then match up the inode numbers. But this is another way that you could do it. And so if I were to stat list 2233, we would see that 3159932 and 3159932, that these are links, and they each have 2 links. Okay, so that's the answer to number 3. Number 4, what are 2 significant differences between hard and soft links? The first major difference, and the one that you will most likely run into, is that hard links cannot span across different partitions. And again, the reason for that is that each partition, when the file system is created on that physical partition, is configured with a set of unique inodes. And so there's no guarantee that creating a hard link, and again, the inode is the same when you're doing hard links, there's no guarantee that the inode will be available on the other file system. So that's one major difference. Soft links can definitely cross file system partitions. Okay, the second major difference is hard links will share the same inode. They have the same inode numbers we just saw. Soft links do not. Another and final example, and this is a question that comes up later in the lab, is when you have soft links, if you remove the file to which you are linked, and the link that you've created is literally pointing at nothing anymore, then you'll get an error message when you try to display the contents. On the opposite side, you have the hard link, and the hard link, even if you remove the linked to file, the hard link that you created still remains, still there. You can edit it, and you don't lose anything, right? So those are 2 major differences. Okay, question number 5 in the lab says, who is the last individual that is given credit as being the author of the utility touch? And so again, this is to get you to take a look at the man pages. So we'll do man touch, and here you have the author section, right? So Mr. Randy Smith is the last individual given credit in the man page for being the author of the touch utility. All right, number 6. What option can be used with the move utility to ensure you are not prompted for a confirmation message asking you if you're sure you want to remove or rename a file name? So we take a look at the man page for MV, right? And right away you can see the force flag. Do not prompt before overwriting, right? So the answer to the question would be either -F or --force, right? And again, become familiar with the man pages. The man pages are extremely critical to your learning the Linux and Unix operating systems that are out there. All right, number 7 is giving you some jobs information, and so I'm going to go ahead and create those jobs right now. 2, 3, 4, 5, and we'll do ampersand, and then we had 5. I think we have, is it 6? 6, 7. There we go. And then we did 2, 3, 4, 5, 6, 7, 8. Okay, so I've created some jobs, and I've put these jobs in the background. So remember, by typing jobs with no arguments, and we actually have an extra one there. So I'm going to kill 4204. And the reason I'm killing that process is I want to make sure, or killing that job and process, is it shows terminated there. And I want to make sure that we don't have that on the stack, and that this matches up with what's in the quiz. All right, so what command was used to produce that output? Right, so simply by typing jobs, I can see the jobs that are running in the background. What command will move job number 6 to the foreground? And that's simply FG space 6. And again, FG stands for foreground. And I hit enter, and as you can see, it is now taking control of the command line because I've pulled this job into the foreground, where it will run like this until completion or until I suspend this job. So by doing Control Z, I can stop the job, right, to regain control of my command line. And we'll come back to that stop job in a second. So C asks you, what does the minus sign represent? So, and before I do that, the minus sign is the next to last job, the next to last most recent job that has been put into the background. What does the plus sign represent? The plus sign represents the most recent job to be placed into the background. So as you would expect, we ran 7 and then we ran 8, and that's why you have the minus sign at the next to last and the plus sign at the last. What command was used to produce the output? And it shows you the output below again, but it shows it with the process ID number. So let's take a look at the jobs command, the man page for the jobs command, right? And as you can see, there's a lot of information in here, a lot of options. Okay, so from the lecture, if you remember, jobs-L will list out the process ID, right? And as you can see, the plus sign is moved because this is the last job that we've manipulated here. So jobs-L lists out the process ID, and this is the process ID for each of these processes. So how can you confirm that, right? And this is actually question 7G, where you could type PS, and then you can confirm. Here's the PID, right? Process ID number, and it should match the process ID numbers above, and it does. Okay. What command will kill job number 3? And as we saw, I can do kill, and I know job number 3 is process 4196. So we'll kill 4196. Oops. There we go. And so that's been terminated. So when I type in jobs now, and you'll notice when I killed 3, it did not shift the numbers of all the other jobs. So 3 has simply been removed, right? So I'm going to put 6 back in the background, right? So now if I type jobs, you can see that 6 is now back and running, right? Okay. So in H, it says, given the output below, explain what has changed and why it has changed. In other words, what key sequences were used to stop job number 3. And so in the lab, it ran through putting job number 3 into the foreground, like we did with job number 6. So let's go foreground number 6. And as again, you can see it pulls that job into the foreground. Now, how do I get it to stop? It's Control Z, at which point it gives me control of the command line back. The process has been suspended. So if I type jobs, you can see it's stopped. And then to push it back into the background so that it's running again, simply BG and the job number. So now when I type jobs, you can see that job 6 is now running again. Okay. And so that was I. What command could be used to restart the job in the background that has been stopped? All right, question number 8 asks you, when did the UL utility first appear as part of any Unix or Linux distribution? And again, man pages, right? Very important that you know how to maneuver through the man pages. And we'll come down to the bottom. So the history, right? Here's the history section. The UL command appeared in 3.0 Berkeley software distribution, right? So that's the answer to the question. All right, number 9, examine the 2 files. So I've got 2 files out there, so I'm going to do an ls-lai on /temp linker blinker clinker link, right? And then ls-lai on /temp lunker blunker clunker link. So we want to take a look at these 2 files. Okay, so immediately we can see that these 2 files, right, are linked together. Okay, so here's the name of the link, and this is the file that it's linked to. Okay, so again, this is the regular file, temp linker blinker clinker link, right? And this file here, lunker blunker clunker link, this is the symbolic link, right? So it says once you've looked at both files, again using the -l option with the ls utility, provide the command that was used to create the association you see. And it says assume you have permissions to read, write, and execute in all of the directories and on all files, right? So if this did not exist, the command to create it, and if you do a man on ls, or I'm sorry, correction, if you do a man on ln for the link, you can see that you do ln, we're going to use an option, and then it's the target file, right? The file to which we are linking, and then the name of the link, right? So I would type in ln, that's a symbolic link we're looking at, right? So -s, and the name of the file that we're going to, or the file that exists, right? The target file would be linker, blinker, clinker link, and we are linking to temp, lunker, blunker, clunker link. So that would be the command, and again we'll scroll back up here, right? Because this is the target file. This is the file that exists. Linker, blinker, clinker link. This is the name of the symbolic link, and the arrow points to the file to which it links, right? So I can't run this command now. I'll probably get an error message here because it already exists, right? All right, what login shell is the user CSI 235A6 currently using? Well, you'll remember from lecture that the etc password file is pretty long, and it stores a very long listing of all of the students, right? And all of the information as well as all the faculty. So if you take a look at the last field in the etc password file is your login shell, right? The first field, oops, as we've discussed, is the user ID. So using a pipeline, I could cat etc password and grep on CSI 235A6, right? At which point I can see that this user prefers the C shell, and this is the login shell that that user is using. Now, another way to run this command, if I'm in my home directory, right, I would cat out etc password and grep CSI 235A6. Now this creates 2 processes, but what if I were to do this? I could simply grep CSI 235A6 from etc password. So this is another way to accomplish the same thing, right? If I was in the etc directory, okay, now I'm in /etc, I could simply grep CSI 235A6 from password. And again, keeping in mind, this is an absolute path name, right? And this is a relative path name. This is a simple file name here, right? So it's not the absolute path name because I'm already in the etc directory where this file is contained, right? And this would give me the same information. Okay, so 3 different ways to answer number 10, or to arrive at the answer for number 10. Number 11, what is the full name of the user PXG on the Vader system? So again, I'm in Etsy, so let's use grep pxg on password. And it's Patricia Gregory, right? And Patricia prefers the TC shell. Okay? So that's how you could have found that. If you were in your home directory, again, I could grep pxg from Etsy password. Remember, having to use that absolute path name, right? All the way from the root directory down to the password file. I get the same answer. I could cat Etsy password and grep on pxg, and we get the same answer. So again, 3 ways you could answer number 11. Number 12, how many users on the class system Vader are using the bash shell as their login shell? And so to arrive at this answer, I could cat Etsy password, grep on bash, and let's see what we get. We get an awful lot. So one way that I could trim this down would be, or to actually not trim it down, so to speak, but to get a quick count would be the WC-L. 597 users, right? So 597 users, WC-L counts the lines that we match. Number 13, provide the absolute path name to the file eyes wide shut. Now, we don't know where this file is at, and this is what we walk through right before we started the lab. I'm going to cat my .bashrc file out. Or actually, we had to make a bin directory in our home directory, right? So you can see I've got a bin directory here. So if I cd into bin and type ls, you can see I've got nothing here, right? ls-lai. So let me check my mail, because I did send something out. So here we go, number 4. And number 4 says, cut and paste this into a file called seeker.bash. So I'll copy, quit from email. So where am I at? I'm in my bin directory, so I'm going to vi seeker.bash. Go into insert mode, paste, and save. And now I want to chmod 700 on seeker.bash. So I'm giving it execute permission, right? Because we're going to run this as a shell script, but we're going to call it from an alias. So if I go back to my mail, you can see number 3 says put the following in your .bashrc file. And so again, I'm going to quit from mail. I'm going to cd to my home directory, and I'm going to vi my .bashrc. And so I have some aliases in here already. So now I'm going to put a new alias in here that calls the seeker.bash script. And again, it's not important that you understand what's in the script right now, simply that you can create the alias, right? And now we can use that alias. So all I need to type is ff, which is our, oops, well, let me do this. Yeah, so we'll go ahead and I'll show you the error that you'll get. So I'm going to type ff, which is the name of the alias, and then eyes wide shut. Now, it's going to come back and tell me ff command not found. And if you remember, if you make any changes to your .bashrc or your .bash profile files, you'll either need to log out and log back in, which is not very convenient, or you can do what's called source the file. And so to source the file, we type .// and the ./ is saying it's in the current directory, and then the slash separates the file name from the directory name. So we're typing dot, which says source, space, ./ which says the file is in the current working directory. The slash separates the current working directory from the file name, and the file name is .bashrc. So I hit enter. Now it's not going to tell you that you have mail, but I just received mail, which is why you're seeing that. So I've just sourced that file. So if I do it again, right, you'll see you do not get a message. That just happened to be perfect timing where an email was arriving at the moment I was sourcing the file. Okay, so now if I type ff eyes wide shut, it's going to search the file system, and there it is. So ff is an alias we've created in our .bashrc file that calls the shell script that we created in the bin directory and then runs the command. And so the argument that the FF utility or alias takes is the name of the file that you're looking for. So what if I was looking for the Vim editor? There we go. You can see it's in a number of locations. What if I was looking for the find command, right? You can see it's in a number of locations. All right, so let's get back to the task at hand. So the next file that we were trying to find was all the right moves. All right, it's in temp really bad movie actors, all the right moves. Okay, and then let's see, I believe that was the last one. No, 15, I'm sorry. So 13 was Eyes Wide Shut, 14 was all the right moves, and 15 says provide, and says using your home directory as the starting point, the relative path name to the file night and day. So first we've got to find that file, right? So let's go ff night and day, and you'll notice that it's in temp. So if I'm in my home directory, how many directories would I have to go back up the directory tree, right, to get to the file night and day? So I could do ls, and we'll do .. slash, and that's going to put us in CSI 135. This .. puts me in Spring 13. That puts me in students. That puts me in U. That puts me at the root directory, and then temp, night and day, right? So the answer would be .. slash .. slash .. slash .. slash temp / night and day. And again, the practicality of this isn't that this is the quickest way to list out the file. Obviously, you could simply type out ls temp, whoops, come back on this one here, Control U, ls temp night and day, right? And that's probably how you would approach it. But again, the premise of the question is to get you to think about absolute path names, relative path names, and in this case, how you use the .. to maneuver your way back up the file system. Okay, number 16 says provide a list of all files on the system Vader that share the inode number 3159992. And we talked about the find command, right? So if you do a man on find, it's going to give you a lot of great information, right? And if you scroll down and take a look at some of the options that are available, so if you use -xdev, it will descend directories on other file systems, right? And so in addition to that, and I think we went right by it up here, and whoops, let me make sure we come down a little further. inum says file has inode number in. It is normally easier to use the -same file test instead, right? And as you can see, you could use inum or same file. So file refers to the same inode as name. Okay, so here's how we can do that. So I could type in find from the root directory -xdev -inum 31599, let me make sure I get the right number here, 3159992, right? Now, we're probably going to see some error messages, so we're going to redirect the output of standard error, and standard error again is the 2, and the greater than says redirect it to dev null, so just send it to the bit bucket. All right, the file is not, oops, sorry, xdev, little typo there, because I know the file's out there. All right, so there is a list of all the files that have that same inode. So what that tells you is those files are hard linked together. Okay, number 17. Given that a user runs the following commands, why are they receiving an error message? And I'm going to go ahead and I'm going to cd into temp, and we'll do make dir quiz 6. So I'll cd into quiz 6 and work this up. And this is what you want to try to do when you're working through the labs, is to work things up. So ln-s, well, let's first create 2 files. So touch foo. So now we're going to create a link to the file foo, right? And we're going to call it bar, okay? So now, when I do foo and bar, you can see there's a soft link with the name of bar, and it's linked that points to the file foo. So I'm going to remove foo now, right? Oops. ls dash, oops, we'll just do ls bar, right? So you can see the file is there, right? But what if I try to cat bar? I get no such file or directory. And again, this goes back to what we talked about earlier, is when on a symbolic link, right, on a soft link, when you remove the file to which the soft link points, that's it. The soft link now no longer points to anything valid. And as you can see, it's blinking saying, hey, I'm pointing to foo, but foo is not there. So what if I touch foo again? What will happen? Let's clear out and do an ls-lai. All right, now you'll notice something important here. It's not blinking anymore. Remember earlier, it was blinking, right? And when it's blinking, it's telling you, hey, I'm pointing to a file that no longer exists. Whereas here, now if I were to cat bar, the file is obviously empty. But if, let's say, let's do this. We'll do uptime, and we'll redirect it to foo. So if now I cat bar, now it contains something. If I remove foo and try to cat bar, we get that same error message, right? So the file that we're linked to has been removed. And again, this is unique to the symbolic or soft link. The hard link does not suffer the same side effect, right? And so I'm going to actually demo that right now. So I'll remove bar, do an ls-lai. So if I touch, well, let's get this blinking thing out of our way here. So ls-lai. So I'll touch foo, right? And I'm actually going to create something. Let's do, let's see who's on the system right now, and we'll send that to foo, right? So now if I cat foo, you can see it's a list of who's logged onto the system. So from here, I'm going to create a hard link, ln foo to bar, right? So if I type ls-lai, you can see same inode number, right? The link count is 2, and so we know from the inode number that these guys are hard linked. Just because this is 2 and they're in the same directory does not mean that they are hard linked together. That's not an automatic to say, hey, these guys are hard linked together. Remember, you've got to match the inode numbers, okay? And so again, let's roll back here real quick and take a look at that find command we ran. And let's change this inode number. Let's make it 3159900. As we would expect, it's going to find these two files, right? So bar and foo, these guys are hard linked together. All right, so now back to the task at hand. So when I cat foo, right, that's what's in there. If I cat bar, I get the same output. Now what if I remove foo? Okay, so let's do clear the screen out here in ls-lai. So I've removed the file to which bar was linked. As you can see, it's only got a single link. So let's double check. Is there another file somewhere out there on the file system that shares that inode number? And the answer is no. It's been removed. But unlike the soft or symbolic link, when I cat the contents of bar out, you can see that they're still there, right? Because again, the hard link is creating a file name that references the same data blocks on the hard drive, right? So it's almost like you're creating a copy of the file with a different name. And given that it can be on, as long as it's on the same partition or file system, it could be the same name somewhere else in the file system, as long as it does not span the partition. Okay, so enough of number 17. On to number 18, it says, which CSI-135 user is logging into the class system Vader from the IP address 96.244.5.89? So again, we could use the last command, and then I could grep, and I could probably get away with .5.89. Let's see. And we certainly can, and that is the user CSI-135E. Now, if I was very trusting, I could also pipe this, and we looked at this command in the first week, right? And this was to print out that first field there, whoops, that we know is going to be the user ID, right? And what if I only wanted to see one user ID? Let's remove the duplicate adjacent lines. So this command right here could narrow it down to the single user who's coming from this IP address, right? Okay, that was number 18. Number 19, what is the plan of the user who is logged onto the class system Vader at 9:17 on Sunday, February 24th? So we're going to go last, and let's take a look at the format here. All right, so Feb 21, so we're going to grep on Feb 24. Whoops. And let's see what that output looks like. So there we go. And then we're looking for the user that was logged on at 9:17. Whoops, I'm going to grep this here. So 9:17. There's our user. So now we know the ID. I could go one step further, right? And we could use that auth command that we saw in the very first week. And remember, that $1 is saying print for me only the first column. And there you go. So now we could use the finger utility. And you can see it says no plan. So you can answer no plan, right? And what we also learned last week in lecture is the permissions on the user's home directory will dictate whether we're able to read their .plan file. So if I use the finger utility on my login ID, you can see it says no plan. However, if I change my directory permissions to 755 on my home directory, and now I run that, you can see it says my plan is that I have no plan. So when you use the finger utility against a user, if you do not have read or execute permissions to get into that user's home directory to take a look at that .plan file, you will not see the plan. So again, I'm in another window right now, changing my home directory back to 700. I run that same command, and it says no plan, right? Okay, so that was number 19. The bonus question, it says, what is the process ID of the cron D process owned by the root user? So the PS command, we know that that shows us the processes, but PS by itself will only show me the processes that I'm running. What if I want to see what's running on the system? And again, let's take a look at the man page, see what the man page says, right? So PSAUX is distinct from PSAUX, so it shows with the dash. Okay, so let's come down a little further. And here you go. Examples. To see every process on the system using standard syntax, you could do PS-E or PS-EF or PS-E capital F or ELY, right? And this is for BSD. Okay, but right now we're dealing with these guys up here. So let's try PS-EF, and I want to grep on cron D, right? Use that pipeline. So here's cron D, and 2755 is the process ID for the cron D process being run by the user root. So what if I do PS-EF and then pipe it to more? We can see the headings, right? PID, process ID. And you don't see cron over here yet. No, still no cron, or cron D, I should say. Come down a little further. And now we're getting close. Trying to remember what the number was. Can't remember the number specifically. We'll run the command again here. Let's do, so it should have been 2755. Alright, so 2755, and here it is right here. So see, this is where it becomes very helpful to know how to create that pipeline, or else you'll end up scrolling through all this output and you may or may not see that process. Just happened to me. Alright, so That is all I have for lab number 6. That's the video tutorial with every question, every step, and in some cases multiple ways to solve the same problem. All right, best of luck, and I will see you on Wednesday evening.